Linear programming. Linear programming is a mathematical technique which uses a linear function in order to minimize or maximize results and optimize operations when faced with a set range of parameters. Linear programming is used in areas such as industrial engineering, business planning, and various areas of science. Businesses use this technique to develop a methodology to run in the most efficient and cost-effective manner and ultimately transform their business model. For example, in manufacturing, linear programming is used to find the most effective way to convert raw materials into products in order to achieve maximum revenue in their business. An assumption that could be made when using linear programming is that the restrictions and constraints being set are exact. For example, the machine hours being 1 hour instead of 1.1 or 1.2. In this example, Company A produces two products X and Y with contribution margins of $30 and $25 respectively. The company has a maximum of 1,200 machine hours and 3,000 labor hours per month. Product X requires 1 machine hour per unit and product Y requires 2 machine hours per unit. Product X requires 3 direct labor hours per unit while product Y requires 2 direct labor hours per unit. Determine the number of product X and Y to be produced to maximize the company's profits each month. We need to produce equations in order to find the most effective work methods for this example. Step 1. Identify the decision variables. Let X equal the number of product X produced, and let Y equal the number of product Y produced. Step 2. Determine the objective function, the sum of the contribution margin. Maximize Z equals 30X plus 25Y, where Z equals the total contribution margin. Step 3. Determine the constraints based on the limited resources available. Machine time, 1x plus 2y is less than or equal to 1,200, and labor hours, 3x plus 2y is less than or equal to 3,000.
Let's begin from joining points of constraint lines. For the first constraint line, when x is 0, y is 1500, and when y is 0, x is 1000. Then we'll do the same calculation for the second constraint line to get the points D and E. Then let's graph the boundary. For the first constraint line, it can go up to 0, 1500, and 1000, 0. That's the line in blue. Then the second constraint line can go up to 0, 600, and 1000, 0, which is the right line. Then let's determine the feasible region. Because x and y are more than or equal to 0, the region should be in the first quartile, which is the yellow area. And now the constraint lines are less than constraint lines, satisfied below the line in downward direction. So their feasible region will be the blue and red area respectively. Therefore, the region satisfying all constraints simultaneously is this area in purple, which we call the feasible region. Now, the linear programming concept says that the optimal solution will occur at one of these corners or extreme points. The point C and D has already been calculated before, but we need some extra calculation to find the intersection A. Let's apply what we learned in Math 123. So we'll substitute the second equation into the first one to get their intersection, which is 900, 150. Finally, let's plug x and y into our objective function and determine which one gives us the highest value. Great, now we found the point A is the most profitable and therefore producing 900 products X and 150 products Y will maximize our profit.
The application of the new model will assist the production process in an effective way, and it tells us the number of product mix we need to produce in order to maximize the profit while we're using the same number of hours in the operation. The industrial production is always known of having negative environmental impacts, so by using this method, the manufacturer can minimize the amount of carbon emission and water use in the production. As a result, the manufacturer can still reach their production quota without compromising the environmental sustainability. This method is also have a positive social impact on the workers who work in the manufacturer as they can work less hours but still achieve the KPI. Therefore, they could have more time to balance between their work and life.